Hi everyone, this video is to show you guys how to use Excel to make a graph. If you're not sure how to do that, this is another video that you can use to help you make a graph in Excel. So we're going to first start off by opening Excel, and I'm just going to create a chart of some data, and we're just going to use an x-axis data, and we'll create two series of y data. So what this is going to do, it's going to allow us to put two lines on a single graph, because we'll do a line graph first. Just making my stuff look nice and neat. Okay. So what I want to do is I want to go to the Insert tab, and I want to choose my graph. What we will typically do is either some sort of scatter plot, or we'll do a column plot. I'm going to show you today how to do a scatter plot. And we'll go ahead and do a scatter plot. You can do them with lines, with smooth lines. Depending on what the data is, you may use different types of scatter plots. Let me just show you. So this is a scatter plot with straight lines. Click on your graph, click on the Design tab, and you go Select Data. Here what you'll do is you'll enter the series name, and so we're just going to select Y1, or you can type in Y1. I prefer to just select it. If you set your chart up right, you can just select it. That way, if you want to go back and change the title of that series, you don't have to update your graph. It'll automatically update it. Choose your X values, and then I'm hitting Tab to go between the fields, and then you'll select your Y1 value, Tab, and then you can hit OK. So that's Y1. Now we need to add Y2. Select the Y2. Select the X values, and then we'll select the Y values. Just hit OK, and there's your line graph. Now I want to take some time here to point out the difference between a scatter plot with lines and markers versus a line graph. And the importance comes whenever your x-axis, let's say, is not continuous. Okay. So let's say you're doing some sort of trial, and you're looking at how a chemical induces cell death, or you're looking at what country you're looking at. Let's say we're looking at concentrations of some chemicals, so 0, 10, 50, all the way to 1,000. We'll say micromolar. Let's just go ahead and put that in there. And then Y is going to represent, let's say, cell concentration. We'll just do cells. So when there's no drug, we expect for there to be a lot of cells. We'll just say it's 10,000. Okay. And as we treat the cells with increasing concentrations of chemicals, we see that the number of cells decreases. Okay, this is very simple explanation. But what I'm going to do is I'm going to plot that same data as a line graph, and then I'm going to go back and I'm going to plot it as a scatter plot. Let's do the line graph first. So select data. We're going to add. We don't really have a series name because we only have one series, but if you want to put a name there, you could. And in here, it's asking you for a value, and we want to select the Y value. Okay. And then we can come here. We can edit our x-axis and hit OK. And what we'll see is we have 0, 10, 50, 100, 250, 500, 1,000. Okay. Looks good. I typically will delete that, but looks good. Okay, looks like a nice curve. Okay, but now let's take that same data and do a scatter plot with. Let's just go with smooth lines. I'm not a big fan of this, but it'll look a little prettier. I'm going to select our data. Now we're adding a scatter. This is a scatter plot. You can put a series name if you want. Since we only have one line, I don't typically do that. Now we have to, since we're doing a scatter plot, we have to tell it what the x-axis is and then what the y values are. And we hit OK. We don't edit anything. Now, what you'll see is that these curves look vastly different. Here we have kind of a convex, if you want to call it that type of curve, and we have a concave curve here. So why does that shape change? Well, what you need to look at is in the line graph, which is this guy here, you see that the distance between each x-axis is the same. However, the value is not. So here we go from 0 to 10. That's a value of 10. Here's 40, 50, 150, 250, and 500. So the axis is not linear. And when you use a line graph function, in the scatter plot, which is this guy here, what you see is we go from 0 to 10, 10 to 50, 50 to 100, 250, and so the distance between the points on the x-axis is the same distance on the x scale. So this is a better interpretation. So you always want to use a scatter graph of some sorts when you are plotting any kind of line data, just to be on the safe side. Now if we go back and we were to plot this data here on a line graph versus a scatter graph, they're going to look the same. Okay. In fact, let's just do that real quick. So we'll go edit. Here, let's just do it this way. Let's go remove, add series name. We'll call it Y1. Boom. Add series name Y2. And we're good here. Okay, now let's go to our scatter plot and let's do the same thing. Y1. We got, since we're doing a scatter, we got to tell it what the x values are. Here are the y values. Y2, x, and y. Now you'll see that these guys are, besides the way it's labeled, I'm just going to delete that for now, they're pretty much the same. The reason why that is now this x-axis here, let's change it just and I'll show you how to do this later on. But there you go. So proof of principle, we get the same looking graph. The reason why is because the distance between each number is the same in our data set. So that's why these two look different. But if your distance between your x-axis the points on your x-axis are not the same between each point, then you're going to get a different looking curve. You're going to get this, and I just pushed undo. There we go. So these lines here represent this data now. Okay? So let's go back, and we'll get rid of that. So you always, whenever you're doing a line, just always by default you use a scatter graph. Okay? So let's go back and we're going to put our line data in. This time I'm going to choose a scatter with only markers, because what I want to do is I want to hit a trend line. And let's kind of jazz this up a little bit to where it's not so nice and perfect. Let's go 1.3, 1.9, 2.8, 4.5. There we go. And we'll do the same thing here. So now this data is not going to be as nice and neat. So let's go ahead and do insert. I'm going to hit scatter, and I'm going to do scatter with only markers. And we're going to select the data. We have two series of data. And let's just call this, before we go on, let's just call this wild type and mutant, for example. Okay. Go back to our design tab, select our data. We'll say wild type. Select our X values. There's our wild type data. Select our mutant, tab, select X values, tab, select our Y values, and then either click or tab and enter, and then hit OK. Hit OK. And this is what our data looks like. See, it's not so nice and pretty anymore. So this would be an example of what a Lineweaver-Burk curve would look like. So the next thing we want to do is I try to use up as much graph space as I can. First I'm going to make this a little prettier. What I want to do with the legend, which is what I have selected here, I want to make the background white. So I'm going to go to Layout, Format, Shape Fill, and I want to select white. Don't select this. This is no fill. You want to select white. And it's just going to make it look a little nicer. If you wanted to put a border around it, you could select Shape Outline, and it puts a little border around there. It doesn't matter. I typically don't put that, but that's just my preference. Now the next thing I want to do, I want to make this just a little bigger, is I want to label the x-axis. Okay. And let's go to Layout. If you want to put a chart title, you can click here and add one of these. I typically don't have you do that because it's more of a distraction than a help. But I do ask you to put axis labels. So the primary horizontal axis is going to be this axis here, and the only selection we have is the title below the axis. You can go into here and fool around with it. I typically don't. I just go primary horizontal, title below, and then you just start typing. So we will say that this is, let's say, drug treatment. So drug concentration, and then you want to put the units. Okay. Actually, let's do this. Let's call it time. That's a little easier to work with. And I'm going to put what units the time is in. And that's important because if I were to just put time, you wouldn't know if I was measuring over the course of hours, over the course of minutes, seconds, years, months, epochs, whatever. And so you always have to put your unit on when you label your axes. So we're going to put time, we're going to put hours. And let's say we're measuring enzyme activity. Okay. For just pulling something out of my butt. Enzyme activity, and we want to put micromoles, moles per hour. Okay. Again, you want to put the unit. Oh, that's not what I meant to do. Sorry about that. We got to. Let's go to primary vertical axis, rotated title, then we'll put enzyme activity, micromoles per hour. Okay. So we have our graphs that are labeled. They are very clearly point out what the x-axis measures and what units that's in. The next thing I want to show you how to do is I'm going to show you how to add a trend line. Now this is going to be important, especially for the enzyme kinetic stuff that you're going to do. What we want to do is select a series, either the blue or the red. We want to go to trend line, and instead of hitting linear trend line, let's go to more trend line options. And I'm going to change a couple. Let's do some. Let's put some values here. Let's make this 0.9 and 0.1. Okay, so they're going to cross the x-axis or the y-axis at a point other than 0. So go back to layout, select our series, go to layout, trend line, more trend line options. You want to hit the linear trend line, and here are a couple things down here that you want to definitely pay attention to. You definitely want to display the equation on the chart if you're asked to use this line to project data or project an answer. R squared value, that tells you how tight the line is to the data. It's not real important for things I have you do, so I wouldn't put that on there. Now if we just stop here, all we're going to do is we're going to see our line the way it is. Also, we want to keep our intercept not at 0, so we don't want to set that to 0, because if we do that, what's going to happen, and look right here as I do this, right now this line is crossing the y-axis at a point other than 0. If we set the intercept to equal to 0, what's going to happen is it's going to adjust the fit of the line so that the line crosses at 0, 0. And we don't want that on this type of graph in the context of a Lineweaver-Burk graph. So we'll take that off. The other thing we want to do is we want to find out where that line crosses the x-axis, and so that's going to be somewhere over here. So we want to project, we want to forecast where the line's going to go. So you can do that here in the forecast. So if you forecast it forward, what happens is it's going to extend the line 1 unit, so it's going to extend it to 11. 1 unit past the data. If you go backwards 1, it's going to extend it 1 unit behind the data that you have. So we'll hit 1 and see what that gives us. Yeah, so that's enough for us to cross the x-axis. So we'll close this. I want to do the same thing to our other series, trend line, more trend line options. We want linear. We want it to go backward 1 period. We want to display the equation on the chart. We want to keep this empty and this unchecked. we'll hit close. And you can keep this on there, or you can remove it. It just depends what the assignment asks for. But now what you have is you have the equations of your two lines, and you can use those equations to calculate where they cross the x and y axis, which is going to be important in figuring out your Km and your Vmax and things like that. Okay? I hope this is helpful. And this is what I expect on a graph that you present. Really, what I'm looking for is that you extend the lines, you show me how you got your formulas, and you can move this around, and you want to make sure that it's formatted nicely. You don't, after we messed around, we had our chart legend over the y-axis. We don't want that. That doesn't look professional, so we want to move that over. Our x-axis is labeled correctly. Our y-axis is labeled appropriately, and as this would be an acceptable Linn Weaver Burk plot.